What if the most terrifying message from the stars wasn't a broadcast, but an object? What if that object wasn't just visiting but reporting back to something else? In 2025, officials confirmed the detection of our solar system's third interstellar visitor, an object designated 3I Atlas. But as they decoded its transmissions and analyzed its impossible flight path, they confirmed a fear that humanity has held for centuries. This wasn't a random rock, it was a messenger. Let's explore this together. The impossible visitor. What if our third confirmed interstellar guest wasn't just wandering through space, but navigating it? When astronomical networks like Pan-STARRS first detected 3I Atlas in early 2025, it shattered every known classification. Unlike previous interstellar visitors, it was traveling at an unusually high interstellar velocity of 45 kilometers per second relative to our Sun, on a trajectory with a hyperbolic eccentricity of over 3.5. But it was its behavior that was truly impossible. It executed deliberate course corrections, moving with a precision that defied any natural explanation. This wasn't a random rock. Its massive coma, a gas and dust cloud stretching 700,000 kilometers across, pulsed with a steady, repeating electromagnetic signal. Unlike the chaotic outgassing of a comet like Hale-Bopp, the trajectory it took was impossibly efficient, using the gravitational wells of planets it passed as if it had a complete map of our system, a feat that takes our own probes years of calculation to achieve. The sheer energy required for these maneuvers, conducted without any visible propellant, suggests a technology that operates outside our known physics. As 3I Atlas carved a path through our asteroid belt with surgical accuracy, it became clear this wasn't an exploration, it felt like an arrival. When physics stopped making sense. Here's where the story takes a sharp turn from a scientific curiosity into a genuine threat. Most objects from beyond our solar system follow chaotic trajectories, their paths dictated by gravity. But 3I Atlas demonstrated something entirely different. Its path allowed it to drift past several planets in ways that maximized gravitational efficiency, a maneuver that reminded JPL engineers of complex gravity assist routes they designed for probes like Voyager. When celestial mechanics experts like Jacques Lascar from the Paris Observatory ran the orbital simulations backward, they discovered something statistically impossible without intelligent intervention. The path of 3I Atlas required navigating through dense meteoroid streams and planetary collision zones with a mathematical elegance that was simply breathtaking. Its trajectory deviated from a purely gravitational path by a measured 0.05 arcseconds per hour, a tiny but constant thrust that had no visible source. It moved like a grandmaster's chess piece on a cosmic board, avoiding every conceivable threat with a precision that suggested either advanced, long-term planning or sophisticated real-time control. This wasn't a random space rock wandering through the cosmos, it was, as some scientists began to describe it, exhibiting piloted behavior. The object that defied reality. When NASA aimed the James Webb Space Telescope at 3I Atlas, the data it sent back challenged our understanding of reality itself. The thermal readings were the first red flag. Instead of chaotic heat bursts, 3I Atlas showed a consistent thermal signature of 250 Kelvin, pulsing with a precision of microseconds. JWST's principal investigator for the observation, Dr. Jane Rigby, noted that the thermal stability was unnatural. Webb's spectrography then revealed hyper-reflective compounds that appeared artificial, a material with a near-perfect albedo of 0.98, reflecting 98% of all light, something not found in nature. But the most disturbing discovery was a faint electromagnetic pulse repeating every 147.13 seconds. It matched the signature of a real pulsar, PSRB 1919+21, yet the object had no magnetic field capable of generating it. It seemed to be mimicking a signal, a form of cosmic camouflage. Webb's infrared analysis also found structural patterns resembling recursive geometric fractals, leading some to float the terrifying consciousness engine theory, comparing it to theoretical concepts like a Matryoshka brain, but on a smaller, mobile scale. The combination of these impossible features in one object moves it from unusual to unequivocally artificial. Two visitors, one terrifying pattern. The mystery deepened significantly when researchers cross-referenced 3I Atlas's electromagnetic signature with archived data from Oumuamua, The comparison revealed something that honestly sent shockwaves through the scientific community. The exact same 147-second frequency had been detected briefly in Oumuamua's data, a faint 3 sigma detection that was initially dismissed as noise. The crucial difference was that 3I Atlas's signal was a powerful, sustained 50 sigma detection, an unmistakable beacon. This discovery, championed by controversial Harvard astronomer Avi Loeb, completely reframed our understanding of both objects. Oumuamua had puzzled scientists, but now a disturbing pattern emerged. The evidence suggested that Oumuamua may have been a reconnaissance probe. If this theory held merit, then 3I Atlas represented something far more significant, not passive observation but active engagement. It was the difference between a single radar ping and a fully operational surveillance system. Some researchers now theorize that Oumuamua was the lock, and 3I Atlas is the key, designed not just to observe but to unlock something, whether buried on our planet or awaiting activation in orbit. When space objects make calculated decisions. The moment we knew for sure we were being actively monitored was the moment it changed course. Just as scientists believed they had mapped its future trajectory, the Very Large Telescope in Chile recorded a subtle but unmistakable 0.05-degree inclination shift, an adjustment of 180 arc-seconds. This wasn't the random drift of a comet. The object veered off its projected arc, aligning with a new vector that brought it closer to Earth's orbital plane. To mission analysts like planetary scientist Dr. Sarah Seeger, the implication was clear: this was a conscious decision. The maneuver occurred just 72 hours after the James Webb Space Telescope began its focused spectroscopic analysis, a time frame confirmed by NASA's Deep Space Network that rules out coincidence. This inclination shift is an incredibly energy-intensive move, and the action wasn't just responsive, it was almost defiant, a clear message that said, "We see you watching us." The mood at the DSN's Goldstone complex as they tracked this impossible change in real time shifted from academic curiosity to profound alarm. Ancient mathematics from the stars. As if its movements weren't enough, independent cryptographers at the SETI Institute, inspired by the lifelong work of pioneers like Dr. Jill Tarter, uncovered something extraordinary. Using Fourier analysis of the pulse's phase modulation, they found precise mathematical ratios hidden within the signal: the golden ratio, Fibonacci sequences, and the first 100 prime numbers encoded in binary. These weren't arbitrary concepts, they represent fundamental codes that appear throughout the natural universe. The precision of these patterns suggested a level of mathematical sophistication far beyond random cosmic noise. Even more disturbing was the dynamic nature of these signals. The mathematical patterns weren't constant, they changed subtly, reacting to solar activity and even our own radio emissions. Most chilling of all, researchers detected a brief disruption, a single skipped pulse that matched exactly with the moment James Webb first locked onto it. The object appeared to know it was being observed and had responded with a mathematical fingerprint that spoke a language older than human civilization itself. Organic chemistry from beyond the stars. It wasn't just a machine, it was carrying the very building blocks of life. James Webb's detailed spectroscopic analysis revealed its outer shell was coated in complex carbon molecules, and its NIRSpec instrument found evidence of adenine, one of the 4 nucleobases in DNA, via clear absorption lines between 260 and 280 nanometers. What was alarming was the purity and organization of these molecules. Unlike the chaotic racemic mixture of amino acids found in the Murchison meteorite, the compounds on 3I Atlas showed a 99.7% levorotatory excess, a homochiral signature that is a smoking gun for biological or artificial synthesis. Astrobiologist Dr. Heather Graham at NASA's Goddard Space Flight Center found the conclusion both thrilling and terrifying. The terrifying implication is that if this is a seed ship, its purpose might not be benevolent, it could be preparing the environment for a subsequent colonization effort. The presence of DNA components suggests a biology that might be eerily compatible or dangerously competitive with our own. When Earth responded to the cosmic visitor. The connection between 3I Atlas and Earth became far more unsettling when a classified high-altitude surveillance balloon managed by the U.S. Antarctic program detected something extraordinary. The balloon's instruments recorded a powerful microwave burst at 23.5 GHz, sharp and centered precisely above the South Pole. At first it was dismissed as interference, but its timing aligned perfectly with another angular shift in 3Y Atlas's trajectory. Just moments after the burst, seismic stations that are part of the global seismographic network recorded ultra-low frequency rumbles across the frozen continent. These deep, resonant frequencies were a perfect 0.0068 Hz, the exact inverse of the 147-second pulses being emitted by 3Y Atlas. The synchronization was impossible to dismiss as a coincidence. Somehow, this visitor appeared to be influencing activity on our own planet, possibly triggering responses from systems buried deep beneath the Antarctic ice. The object wasn't just passing by, it was actively interacting with Earth in ways that suggested a technological sophistication far beyond our current understanding. The asteroid belt death run. Right now, 3I Atlas is navigating a cosmic minefield, and it's doing so with terrifying ease. Its current path takes it directly through the main asteroid belt, traversing the dense Kirkwood gaps at over 60 kilometers per second. Unlike most comets, which have highly inclined orbits, 3Y Atlas is cutting directly through the belt's core. Planetary defense expert Dr. Amy Mainzer, former principal investigator of the NEOWISE survey, noted that its 700,000-kilometer coma is interacting with millions of untracked objects. More astonishingly, minor course corrections have been observed, suggesting it's actively avoiding even meter-sized debris with impossible precision. This avoidance system must be processing the trajectories of over 1.5 million known objects in real time, a feat of computation that dwarfs anything on Earth. Its journey isn't a dangerous run so much as a demonstration of effortless superiority over a hazardous environment, adjusting its path by mere hundreds of kilometers to avoid potential impacts. Rewiring our solar system's neural network. Scientists have now discovered that 3I Atlas's interaction extends far beyond simple gravitational effects. Its complex, dusty plasma envelope is actively interacting with the solar system's magnetic field, creating what researchers are calling an electromagnetic web effect. As 3I Atlas cuts through the inner solar system, it could be generating packets of charged dust that flow along the sun's natural electric currents toward Earth, potentially triggering geomagnetic storms. But the most disturbing discovery is the most recent. Observations from the Allen Telescope Array show that 3Y Atlas has begun emitting a secondary signal, a lower frequency, longer pulse at 700 MHz pointed directly toward the Orion constellation. As SETI astronomer Seth Shostak noted, a signal not pointed at us is infinitely more chilling. Some researchers believe it's calling for reinforcements. Others think it's reporting back on its findings. But either way, one conclusion seems undeniable. This was never just an interstellar rock. This was a node, a probe, a messenger, broadcasting to something else that is still on its way. The universe has sent us messengers, and we are only just beginning to learn their language. The mysteries of Oumuamua and other interstellar visitors remind us that we are part of a vast, interconnected cosmos filled with wonders we are yet to discover. The journey into the unknown continues. Don't forget to like, subscribe, and hit the bell icon for more deep dives into the frontiers of science. Thank you for watching Stellar Tech. When astronomers discovered Oumuamua in 2017, they thought they'd found a typical interstellar visitor, just a chunk of rock from another star system passing through our cosmic neighborhood. But, 7 years later, the more we learn about interstellar objects, the stranger Oumuamua becomes. The recent discovery of 2I/Borisov and now 3I/Atlas has given scientists a baseline for what normal interstellar objects should look like. The problem? Oumuamua doesn't match the pattern at all. Today we're exploring how new interstellar discoveries are making our first cosmic visitor look increasingly alien and mysterious.
The discovery of 3I Atlas.
January 2025 marked a milestone in astronomy, when the Atlas asteroid survey detected what appeared to be a routine asteroid, designated C2023A3. However, months of orbital analysis revealed something extraordinary. This wasn't a solar system object at all, but our third confirmed visitor from interstellar space. Larry Deneau, principal investigator of the Atlas project at the University of Hawaii, initially dismissed the object as typical space debris until precise astrometry revealed its hyperbolic trajectory. Unlike Oumuamua's mysterious behavior, 3I/Atlas behaved exactly as astronomers expected an interstellar comet should. As it approached the sun, the object developed a classic comet tail, began outgassing water vapor and carbon monoxide, and showed predictable brightness variations consistent with a rotating, icy nucleus. Robert Warwick, the same astronomer who discovered Oumuamua with the Pan-STARRS telescope, confirmed that 3I/Atlas displayed all the characteristics absent from our first interstellar visitor. The object's composition matched theoretical predictions for comets formed in other star systems, with spectroscopic analysis revealing familiar water ice, carbon dioxide, and rocky material. This normal behavior made Oumuamua's anomalies even more puzzling and significant. The Oumuamua discovery. October 19, 2017, changed our understanding of the cosmos when Pan-STARRS 1 telescope in Hawaii detected a fast-moving object unlike anything seen before. Robert Warwick was conducting routine asteroid observations when he noticed an object moving too quickly to be bound by the sun's gravity. Initially catalogued as C2017U1, then reclassified as A2017U1 when no comet tail appeared, the object finally received the designation 1I/Oumuamua, the first confirmed interstellar visitor to our solar system. The Hawaiian name means scout or messenger from afar, chosen by the Pan-STARRS team to honor its discovery location. Oumuamua was already leaving the solar system when detected, having made its closest approach to the sun weeks earlier. The object's discovery timeline was incredibly tight. Astronomers had only a few weeks to observe it before it faded beyond detection limits. European Southern Observatory's Very Large Telescope and other major observatories worldwide immediately began tracking campaigns. The International Astronomical Union had to create an entirely new designation system for interstellar objects, with the I prefix distinguishing visitors from other star systems from ordinary asteroids and comets born in our solar system. Oumuamua's strange properties. Oumuamua defied every expectation astronomers had about interstellar objects through its bizarre physical characteristics and behavior. The object measured approximately 400 meters long and only 40 meters wide, creating an unprecedented 10:1 aspect ratio that made it the most elongated object ever observed in space. Alan Fitzsimmons from Queen's University Belfast led spectroscopic studies revealing that Oumuamua's surface was dark reddish in color, similar to objects in the outer solar system that have been irradiated by cosmic rays for millions of years. The object rotated every 7.3 hours, creating dramatic brightness variations as different faces reflected varying amounts of sunlight toward Earth. Unlike typical asteroids or comets, Oumuamua showed no signs of outgassing, dust production, or tail formation, despite passing close to the sun, where volatile materials should have vaporized. Marco Michelli from the European Space Agency discovered that the object was gradually accelerating away from the sun, behavior that suggested comet-like outgassing but without any visible evidence of gas or dust emission. Temperature modeling indicated that Oumuamua's surface should have been hot enough to sublimate water ice, yet no outgassing was detected by even the most sensitive instruments available to astronomers worldwide. The acceleration mystery. The most perplexing aspect of Oumuamua emerged when, precise astrometric measurements revealed the object was accelerating away from the sun without any visible mechanism to explain this behavior. Marco Michelli and his team at the European Space Agency used Hubble Space Telescope observations combined with ground-based tracking data to determine that Oumuamua was experiencing a small but measurable non-gravitational acceleration. The acceleration was approximately 100,000th of a meter per second squared, tiny, but significant enough to affect the object's trajectory over time. For typical comets, this type of acceleration results from the rocket effect of outgassing materials as solar heating vaporizes ice and other volatiles from the nucleus. However, Oumuamua showed absolutely no signs of outgassing, dust production, or comet tail formation that would account for the observed acceleration. Davide Farnocchia from NASA's Jet Propulsion Laboratory confirmed that the acceleration was real and not an artifact of observational error or gravitational perturbations from known solar system bodies. The mystery deepened when astronomers realized that the acceleration was decreasing as Oumuamua moved farther from the sun, exactly matching the pattern expected from solar-powered outgassing, but without any detectable outgassing occurring. Scientific investigations. NASA's Spitzer Space Telescope conducted crucial observations that, honestly, deepened the Oumuamua mystery rather than solving it. Davide Farnochia led the Spitzer investigation, searching for any infrared signature that might indicate outgassing or thermal emission from the object's surface. The results were shocking. Spitzer detected no thermal emission whatsoever, suggesting Oumuamua's surface was either extremely small or highly reflective. The albedo measurements indicated that Oumuamua reflected approximately 10 times more sunlight than typical asteroids, giving it an unusually bright mirror-like surface. Alan Harris from the German Aerospace Center collaborated on thermal modeling that revealed Oumuamua must be either much smaller than initially estimated or composed of highly reflective material, unlike any known solar system object. The James Webb Space Telescope was unfortunately not yet operational during Oumuamua's passage, but ground-based spectroscopy by teams led by Alan Fitzsimmons revealed a surface composition that appeared similar to organic-rich asteroids from the outer solar system. However, the complete absence of water vapor, carbon monoxide, or dust emission remained unexplained by any conventional model of interstellar object composition and behavior.
The alien hypothesis.
Abraham Loeb, chair of Harvard University's astronomy department, sparked worldwide controversy by proposing that Oumuamua might be an artificial object created by extraterrestrial intelligence. In his analysis published in astrophysical journal Letters with Shmuel Bialy, Loeb suggested that Oumuamua's unusual acceleration could be explained if it were a light sail, an ultra-thin sheet of material propelled by solar radiation pressure. The hypothesis proposed that Oumuamua might be debris from alien technology, possibly a defunct probe or even a deliberately sent investigation device from another civilization. Loeb calculated that a sail-like object only millimeters thick but hundreds of meters wide could experience exactly the type of acceleration observed without requiring outgassing. The artificial origin theory gained traction when Loeb noted that Oumuamua's extreme elongation and high reflectivity were consistent with constructed materials rather than natural rock or ice. NASA's reaction was skeptical but respectful, with Thomas Zurbuchen, former associate administrator for science missions, acknowledging that extraordinary claims required extraordinary evidence but shouldn't be dismissed without investigation. Loeb's hypothesis divided the scientific community, with many astronomers arguing that natural explanations should be exhausted before considering extraterrestrial origins for unusual but not impossible celestial phenomena.
The dark comet theory.
Darrell Seligman from the University of Chicago and Gregory Laughlin from Yale University proposed a natural explanation for Oumuamua's mysterious behavior through their innovative dark comet hypothesis. Their theory suggested that Oumuamua was composed primarily of hydrogen ice, frozen molecular hydrogen that would be invisible to most telescopes and leave no detectable outgassing signature. Hydrogen ice sublimates at extremely low temperatures and produces gas that's nearly impossible to detect with conventional instruments, potentially explaining the acceleration without visible outgassing. The theory required Oumuamua to have formed in an exceptionally cold environment, possibly in the outer regions of another star system where temperatures were low enough for hydrogen to freeze solid. Seligman calculated that objects composed of hydrogen ice could maintain their integrity during interstellar travel, and would begin sublimating as they approached any star, producing the rocket-like acceleration observed. The hydrogen ice hypothesis gained support from theoretical models, showing that such objects could form naturally in protoplanetary disks under specific conditions. However, the theory faced criticism because hydrogen ice has never been observed in space, and would require extraordinary preservation during Oumuamua's millions of years journey through interstellar space before reaching our solar system.
The ongoing debate.
Abraham Loeb remained unconvinced by the dark comet theory, publishing detailed critiques arguing that the hydrogen ice hypothesis created more problems than it solved. In his book Extraterrestrial: The First Sign of Intelligent Life Beyond Earth, Loeb pointed out that hydrogen ice would require formation temperatures of -434 degrees Fahrenheit, colder than most regions of interstellar space. He argued that such an object would likely sublimate completely during its journey to our solar system, making survival impossible over the millions of years required for interstellar travel. Darrell Seligman responded with refined calculations showing that sufficiently large hydrogen ice objects could retain enough material to remain intact, but acknowledged the theory required exceptional formation conditions. The scientific community remained divided, with most astronomers favoring natural explanations while acknowledging the limitations of current observational data. European Southern Observatory astronomers conducted follow-up studies of other interstellar objects, finding that normal comets like 2I/Borisov behaved exactly as traditional comet models predicted, making Oumuamua's anomalies even more striking. The debate highlighted fundamental gaps in our understanding of interstellar object formation and composition that persist today.
Project Lyra mission concept.
Andreas Hein from the Initiative for Interstellar Studies and Zach Manchester from Stanford University developed Project Lyra, an ambitious mission concept designed to intercept and study Oumuamua before it disappears forever into interstellar space. The proposed mission would require launching by 2025 to have any chance of reaching the object, using Jupiter and possibly Saturn for gravitational assists to achieve the enormous velocity needed. ESA's Advanced Studies program examined the technical feasibility, concluding that a small CubeSat could theoretically reach Oumuamua by 2054 if launched on a powerful rocket like NASA's SLS or SpaceX's Falcon Heavy. The mission would carry miniaturized instruments including cameras, spectrometers, and possibly a penetrator to sample the object's interior composition. Project Lyra faces enormous technical challenges, including the need for spacecraft to survive decades in space while maintaining operational capability upon arrival. The mission cost estimates range from $500 million to several $billion, making it financially challenging for most space agencies. Despite these obstacles, Project Lyra represents humanity's best chance to definitively determine Oumuamua's true nature and resolve the debate between natural and artificial origins that has captivated both scientists and the public worldwide. The Future Hunt. The Vera C. Rubin Observatory, beginning operations in 2025, promises to revolutionize our ability to detect and study interstellar visitors before they leave the solar system. Mario Jurek from the University of Washington leads the legacy survey of space and time that will discover an estimated 1 interstellar object per year, a dramatic increase from our current rate of discovery. The observatory's wide-field camera and rapid survey capabilities will provide weeks or months of advance warning when interstellar objects approach, allowing detailed study missions to be planned and executed. NASA's Interstellar Probe mission, currently in development, could potentially encounter interstellar objects during its journey beyond the solar system. The comparison between Oumuamua 2I/Borisov and 3I/Atlas has already revealed that our first visitor was genuinely anomalous, rather than representative of typical interstellar objects. As we discover more interstellar visitors, the statistical sample will help determine whether Oumuamua was a rare natural phenomenon or something more extraordinary. The scientific consensus suggests that while artificial origins remain possible, natural explanations involving exotic compositions or formation mechanisms are more likely. However, the mystery of Oumuamua has permanently changed how astronomers approach the study of interstellar objects and the search for potential technosignatures in space. Oumuamua arrived as a mysterious messenger from another star system and left as one of astronomy's greatest unsolved puzzles. The discovery of normal interstellar objects like 2I/Borisov and 3I/Atlas has only made our first visitor appear more anomalous and extraordinary. Whether it was exotic hydrogen ice, alien technology, or something we haven't yet imagined, Oumuamua proved that the universe still holds surprises that challenge our understanding. Subscribe to Stellar Tech for more cosmic mysteries that push the boundaries of science and keep us wondering what else might be traveling between the stars. It started as nothing more than a flicker in the data, a cold, silent speck moving far faster than anything that should have been out there. But then, the James Webb Space Telescope captured the first real image of 3Y Atlas, confirming its presence and reigniting debates about its origin. Now traveling at 152,000 miles per hour from the depths of interstellar space, this mysterious visitor is rewriting what we know about cosmic travelers. The flicker in the data. The flicker in data that led to the discovery of 3Y Atlas was first noticed by astronomer Larry Deneau using the Atlas survey system in early 2025. Initially, the object appeared as a faint point source barely distinguishable from background noise, traveling at an extraordinary speed that defied expectations. Rapid follow-up observations from telescopes worldwide confirmed its hyperbolic trajectory, indicating an interstellar origin beyond our solar system. The discovery highlighted the increasing capability of modern automated sky surveys and the importance of advanced image processing techniques in spotting elusive cosmic phenomena. 3I Atlas's initial data sparked excitement and mystery in equal measure, leading to widespread international scientific collaboration to understand its true nature. The detection demonstrated the effectiveness of coordinated astronomy projects working in concert across hemispheres to capture fleeting interstellar visitors. What began as a mere computational anomaly quickly evolved into one of the most significant astronomical discoveries of the decade, challenging our understanding of what travels through the void between stars and forcing scientists to reconsider fundamental assumptions about interstellar objects. 152,000 mph from the void. Moving at an incredible velocity of approximately 152,000 miles per hour, 3Y Atlas stands as one of the fastest objects ever recorded within our solar system's boundaries. Its extraordinary speed distinguishes it from typical asteroids or comets native to our cosmic neighborhood, definitively confirming its extragalactic origins. The precise velocity measurements were obtained using combined data from the Hubble Space Telescope and ground-based observatories worldwide. This phenomenal speed suggests a trajectory completely uninfluenced by our sun's gravitational pull, affirming that 3I Atlas is truly a visitor from another star system. Scientists involved in tracking the object, including Dr. Davide Farnochia at NASA's Jet Propulsion Laboratory, are racing against time to gather detailed observations before it disappears forever into the cosmic void. The object's rapid passage through our observational field poses unprecedented challenges for data collection, requiring lightning-fast coordination among observatories globally to maximize information retrieval during its brief transit. Such extraordinary velocity raises fundamental questions about the forces that accelerated this object to such speeds and whether natural processes alone could account for its remarkable journey through interstellar space.
3 visitors, 7 years.
Over the span of 7 years, humanity has documented the arrival of 3 confirmed interstellar visitors: Oumuamua in 2017, 2I Borisov in 2019, and now 3I Atlas in 2025. Each visitor has brought unique characteristics that challenge our understanding of interstellar objects and their origins. Oumuamua puzzled scientists with its cigar-like shape and unexplained acceleration, while 2I Borisov displayed traditional comet behavior with visible outgassing. 3Y Atlas represents perhaps the most enigmatic of the 3, combining unprecedented size with unusual physical properties. The increasing frequency of these detections suggests either improved observational capabilities or a genuine increase in interstellar traffic through our solar system. Dr. Alan Fitzsimmons from Queen's University Belfast notes that statistical models predicted we should encounter one interstellar object every few years, yet the diversity among our 3 visitors exceeds all theoretical expectations. This pattern has prompted astronomers to reconsider whether we're witnessing random cosmic wanderers or something more systematic. The progression from Oumuamua's mysteries to 3I Atlas's apparent technological signatures suggests an escalating complexity that challenges conventional explanations for these cosmic visitors.
James Webb's metallic discovery.
Despite its immense size, 3I/Atlas exhibits distinctly metallic characteristics not commonly observed in natural celestial bodies traveling through space. Recently, the James Webb Space Telescope captured unprecedented infrared images revealing highly reflective surfaces and spectral signatures indicative of engineered materials rather than typical rocky or icy compositions. Dr. Jane Rigby from the Space Telescope Science Institute leads the comprehensive analysis of these groundbreaking findings that challenge conventional understanding of interstellar objects. The spacecraft's sophisticated instruments detected unusual heat emission patterns consistent with metallic alloys and composite materials rather than the typical signatures expected from cometary ices or rocky asteroids. These observations fundamentally challenge conventional cometary models and provide compelling evidence supporting theories about the object's potential artificial origin. The metallic properties suggest advanced engineering capabilities far beyond current human technology, with surface materials that appear designed to withstand the harsh conditions of interstellar space. The discovery has prompted intense international collaboration, as scientists attempt to understand how such materials could survive millions of years of cosmic radiation and micrometeorite bombardment during the object's journey between star systems.
The machine that steers itself.
Detailed tracking of 3I/Atlas reveals subtle but unmistakable evidence that it actively maneuvers through space, strongly suggesting the presence of an autonomous guidance system. Dr. Amir Siraj from Harvard University highlights observational data showing minute trajectory corrections that cannot be explained by gravitational influences or solar radiation pressure alone. These course adjustments occur with mathematical precision, indicating sophisticated onboard navigation capabilities. Experts hypothesize the presence of an advanced propulsion mechanism or intelligent navigation system actively controlling the object's path through our solar system. Such self-steering capability would represent a technological achievement far beyond anything in humanity's current arsenal, suggesting engineering by a civilization with capabilities we can barely comprehend. The subtle nature of these adjustments indicates a system designed for stealth and efficiency, rather than dramatic maneuvers. Analysis suggests the object may be following a predetermined flight path, possibly executing a systematic survey of our solar system's major bodies. This revelation intensifies scientific debates about whether 3I/Atlas represents a natural interstellar object, or an intelligently designed probe conducting reconnaissance of our cosmic neighborhood, with sophisticated artificial intelligence guiding its every movement. Information blackout. In recent months, astronomical observations of 3I/Atlas have been plagued by mysterious communication disruptions that some scientists describe as an emerging information blackout. Data streams from major observatories occasionally suffer unexplained interruptions, creating frustrating gaps in the continuous monitoring required for comprehensive analysis. Dr. Sarah Seeger from the Massachusetts Institute of Technology warns that these systematic blackouts are hindering critical data collection during the object's closest approach to Earth. The disruptions appear to follow patterns that cannot be attributed to equipment failures or atmospheric conditions, leading to speculation that the object may employ active measures to obscure detailed observation. Information loss challenges astronomers to devise innovative observational strategies and backup systems to maintain contact during the object's rapid transit. Some researchers theorize that 3I/Atlas possesses adaptive countermeasures designed to limit scrutiny from potential observers. The timing of these blackouts often coincides with moments when the most sensitive instruments would normally capture their highest quality data. This phenomenon has prompted the development of new redundant observation networks and the deployment of multiple independent systems to circumvent whatever mechanism might be causing these mysterious data interruptions.
Adaptive shielding technology.
Scientists, have developed theories suggesting that 3I/Atlas employs some kind of sophisticated adaptive shielding technology to survive the extreme conditions of interstellar space over, potentially millions of years. Dr. Monica Grady from the Open University explains that such advanced shielding systems might dynamically protect the object from cosmic radiation, solar particle streams, and micrometeorite impacts while maintaining its structural integrity. Evidence from variable brightness patterns and sophisticated thermal management systems supports this revolutionary hypothesis about the object's survival mechanisms. Now, these adaptive shields would enable prolonged operational capability during close stellar encounters, making the object far more than just a simple interstellar comet. If this theoretical technology is confirmed through continued observation, it would, quite frankly, fundamentally revolutionize human understanding of material science and extraterrestrial engineering capabilities. The shielding appears to respond to environmental changes, adjusting its properties based on local radiation levels and particle densities. Such technology, it would require advanced sensors and automated response systems working in perfect coordination. The implications extend far beyond just academic interest, suggesting that 3I/Atlas represents an engineering achievement that could provide blueprints for humanity's own future interstellar missions. Understanding these protective mechanisms could unlock secrets essential for our survival during extended journeys between star systems.
The Ancient Probe Network.
So, recent theoretical frameworks propose that 3I/Atlas represents a component of an ancient probe network designed to systematically explore and monitor galactic environments across vast timescales. Dr. Frank Drake, founder of modern SETI research, has discussed the possibility of coordinated reconnaissance systems deployed by advanced civilizations to study emerging planetary systems throughout the galaxy. These theoretical probes might maintain communication through quantum entanglement or, other exotic mechanisms currently beyond human technological comprehension. Evidence suggests such a network could have been deployed millions or even billions of years ago by a highly advanced civilization with capabilities spanning galactic distances. The probes would operate with extreme longevity, possibly self-repairing and adapting to changing cosmic conditions over geological timescales. Exploring 3I/Atlas might offer unprecedented insights into this enigmatic interstellar monitoring system and reveal the intentions of its creators. The network hypothesis explains the increasing frequency of interstellar visitors and their apparent technological sophistication. Such a system would represent the ultimate expression of scientific curiosity and technological achievement, allowing a civilization to study the development of life and intelligence across thousands of star systems simultaneously, while, remaining largely undetected until their technology is sufficiently advanced for meaningful contact. Prime numbers in heat signatures. Scientists analyzing thermal emissions from 3I/Atlas have detected periodic fluctuations that correspond remarkably to prime number sequences, creating patterns unlikely to arise from any known natural process. Dr. Seth Shostak from the SETI Institute emphasizes that such mathematical precision in thermal signatures strongly indicates intentional signaling by an intelligent source rather than random physical phenomena. The presence of prime-numbered cycles in heat emissions represents a form of universal mathematical communication that any technologically advanced civilization would recognize. These observations add compelling evidence to theories that 3I/Atlas harbors sophisticated technological features specifically implemented to communicate or encode information for other intelligences. The mathematical precision of these thermal patterns suggests deliberate design rather than coincidental physical processes. Researchers are working to decode these numerical sequences, hoping they might contain more complex information about the object's origins or mission. The use of prime numbers as a communication method demonstrates sophisticated understanding of mathematics as a universal language. This discovery represents potentially the first confirmed technological signal from an extraterrestrial source, marking a watershed moment in humanity's search for cosmic intelligence and fundamentally altering our understanding of our place in the universe. We were never the observers. The accumulating evidence surrounding 3I/Atlas fundamentally challenges humanity's assumption that we are the primary observers of cosmic phenomena. Dr. Avi Loeb from Harvard University argues that this interstellar visitor demonstrates clear evidence of extraterrestrial intelligence actively monitoring and studying planetary systems throughout the galaxy. Observational data suggests these cosmic visitors are neither passive wanderers nor accidental tourists, but may represent fundamentally proactive agents in galactic scientific endeavors. This paradigm shift forces humanity to reconsider our place in the cosmic hierarchy and acknowledge the possibility that we have been subjects of study rather than the sole investigators. The revelation that advanced civilizations may have been observing Earth for extended periods alters philosophical and scientific perspectives about human uniqueness and cosmic significance. The systematic nature of these visits suggests a level of galactic organization and scientific methodology that, honestly, dwarfs human capabilities. Recognition that we may have always been monitored by superior intelligences challenges anthropocentric worldviews and demands humility in our cosmic perspective. This discovery marks the beginning of humanity's true integration into a galaxy populated by intelligence far exceeding our own technological and scientific achievements. The remarkable data captured by the James Webb Space Telescope has propelled humanity into a new era of cosmic discovery and understanding. As the secrets of 3I/Atlas continue to unfold, we find ourselves confronting the profound possibility that we are not alone in the universe. The ongoing study of this extraordinary visitor challenges our fundamental notions of life, technology, and our place in the cosmos. Stay with Stellar Tech as we continue following these groundbreaking developments, seeking truth among the stars, and preparing for humanity's next chapter in cosmic exploration. Right now, 15 billion miles from Earth, humanity's most distant messenger is revealing secrets that are, honestly, rewriting our understanding of space. Voyager 1 crossed into interstellar space back in 2012, becoming the first human-made object to leave our solar system's protective bubble. But after a terrifying communication blackout in 2023, the spacecraft came back online with data that absolutely stunned scientists. The space between stars isn't the empty void we imagined, it's actually a dynamic, structured environment filled with cosmic weather, invisible boundaries, and phenomena that challenge everything we thought we knew about our galaxy.
The silent crisis.
April 2024 brought relief after months of cosmic terror. Voyager 1 had gone completely silent, transmitting only garbled signals that made no sense to NASA engineers at the Jet Propulsion Laboratory. After 46 years of faithful service, humanity's most distant explorer was dying. The culprit was a corrupted memory chip, likely damaged by a cosmic ray strike. The very phenomenon Voyager was studying had wounded it. Engineers faced an unprecedented challenge, performing brain surgery on a spacecraft using 1970s technology from 15 billion miles away, where radio signals take over 22 hours for a round trip. The rescue operation required rerouting code into backup memory areas, essentially giving CPR to a robot that predated most modern computers. By May 2024, the patient showed signs of life, with all 4 science instruments gradually coming back online. This wasn't just an engineering triumph, it was humanity's lifeline to the only measurements we have from beyond our solar system.
Magnetic mysteries beyond the edge.
The first shock came from Voyager's magnetometer readings after crossing the heliopause. Scientists expected some differences, but the interstellar magnetic field showed a dramatic misalignment compared to our sun's magnetic influence. This wasn't a gradual transition, it was a sharp boundary suggesting something far more significant than anyone had anticipated. The readings point to Voyager 1 entering a magnetic turbulence zone where galactic magnetic fields twist and reconnect in ways that could, honestly, reshape our understanding of galactic structure. These aren't small ripples in space, they're fundamental forces operating on scales larger than our entire solar system. The magnetic field orientations Voyager measures might even channel cosmic material into denser regions, potentially influencing where new stars form in our region of the galaxy. Each measurement reveals that interstellar space has its own magnetic weather patterns, invisible highways of force that guide particles across vast cosmic distances. The spacecraft continues to detect these magnetic anomalies, proving that the space between stars is far more structured and dynamic than anyone predicted.
The cosmic ray avalanche.
Crossing into interstellar space triggered an immediate and honestly shocking discovery. Voyager's cosmic ray detector recorded a sharp spike in high-energy particles accelerated to nearly light speed by distant supernovae and black holes. The increase wasn't gradual, it was abrupt, like stepping through an invisible barrier. This revelation exposed how effectively our sun's heliosphere shields Earth from the harsh radiation environment of interstellar space. We're living in a cosmic oasis, protected from particle bombardment that would be lethal to unshielded life. But the pattern isn't uniform. Voyager has detected systematic variations, suggesting natural radiation corridors, cosmic highways where particles preferentially flow. These measurements hint at larger galactic structures, possibly ancient scars left by stellar explosions that shaped our neighborhood millions of years ago. The spacecraft may be detecting pressure gradients that map onto invisible architecture spanning light years. Each cosmic ray measurement reveals more about the galactic environment, showing that we're not just measuring local conditions, but glimpsing the aftermath of cataclysmic events that continue to influence our cosmic neighborhood today.
Whispers in the void.
You know, the silence of space doesn't actually exist. Voyager's plasma wave instrument has completely shattered the old myth of cosmic emptiness by detecting these constant low-frequency oscillations that just permeate interstellar space. And these aren't just random fluctuations, no, they're structured signals, suggesting that the space between stars has its own unique acoustic signature. The instrument has even picked up multiple plasma density spikes, kind of like pressure waves moving through an invisible medium out there. Scientists think these could be shock fronts left behind by ancient supernovae that exploded thousands of years ago, still rippling through the interstellar medium today. So Voyager isn't just drifting through emptiness, it's flying through an invisible fog with its own distinct layers and properties. Some regions are hotter, others are denser, and together they create this complex three-dimensional structure that actually resembles weather patterns a lot more than the uniform void scientists once expected. This cosmic hum, it's really the background activity of our galaxy, a constant whisper from the space between stars. The plasma waves are revealing that interstellar space has its own dynamics, its own currents and temperatures, creating an environment that's far more active than anyone could have imagined.
Interstellar weather patterns.
Voyager 1 has actually passed through at least 2 distinct interstellar cloudlets since crossing the boundary, and this has revealed that the space between stars has structure, kind of like an ocean with currents and eddies. These aren't visible clouds though, they're regions where the plasma, dust, and gas density suddenly changes by factors of 2 or even 3 times. The spacecraft's instruments show evidence of these structured plasma ripples with clear boundaries, almost like atmospheric fronts out in space. NASA scientists now believe our sun is moving through the local interstellar cloud, and Voyager is helping to define its outer edges right now. This cloud exists inside the much larger local bubble, which is this enormous cavity created by ancient supernovae. These density shifts, they actually affect Earth's cosmic ray exposure over millennia. As our solar system drifts through different interstellar environments at 450,000 miles per hour, the radiation environment at Earth subtly changes, and that can potentially affect cloud formation and even mutation rates in living organisms. Voyager is showing us that interstellar space isn't just a straight path, it's really a gauntlet of invisible forces that create this complex, ever-changing cosmic landscape, complete with its own weather systems and boundaries.
Digital resurrection.
So, the 2023 communication crisis nearly ended humanity's only direct window into interstellar space. For months, Voyager 1 was transmitting incomprehensible data, its memory corrupted by cosmic ray bombardment. NASA engineers were suddenly facing one of their greatest challenges: remotely repairing a spacecraft that's actually older than most of their careers, and doing it with technology from the Carter administration no less. The solution took unprecedented ingenuity, rerouting decades-old code into backup memory areas while somehow maintaining all the critical functions across a 15 billion-mile gap. And every command took 22 hours to reach the spacecraft, so real-time troubleshooting was just impossible. The team basically performed remote surgery on a patient they couldn't see or touch. In April 2024, they finally had a breakthrough when basic telemetry resumed, and that was followed by the gradual revival of the scientific instruments. By June 2024, all 4 active science instruments were functioning again. This wasn't just an engineering triumph, it was humanity's lifeline to the only measurements we have from beyond our solar system's protective bubble. The rescue operation showed that even 1970s technology could be revived through innovative engineering, buying us precious additional years of interstellar data collection.
Mapping the invisible galaxy.
Voyager 1 is creating something, well, truly unprecedented, a navigational chart of interstellar space. With every data packet sent back, scientists are able to construct 3-dimensional models of the Milky Way's magnetic and radiation zones, using Voyager's measurements as crucial anchor points. This, honestly, represents the first real-scale cartography of our stellar neighborhood. It's a bit like having a weather satellite, but for the cosmos. The cosmic ray gradients, particle density readings, and magnetic field orientations are revealing natural shields and danger zones, and these could really determine whether humans can safely venture beyond our solar system. The radiation environment that Voyager measures is far more intense than what astronauts face in Earth orbit, which makes these maps absolutely crucial for any future interstellar missions. Some astrophysicists even believe the structures Voyager is mapping may influence star formation patterns across our galactic region. Quietly, the spacecraft is drawing the first blueprint of the space between stars, creating detailed models that get refined with every new measurement. This mapping project has, well, become the foundation for understanding how to navigate the void between stars, potentially guiding future spacecraft through the safest corridors of interstellar space.
The protected oasis.
Voyager's measurements have revealed a profound truth about Earth's place in the cosmos. Our solar system exists within a protective bubble that shields us from an environment far more hostile than anyone realized. The dramatic increase in cosmic radiation beyond the heliopause demonstrates how effectively the sun's magnetic field deflects dangerous particles that would otherwise bombard our planet. This discovery reframes Earth not just as our home, but as our shelter in a cosmic storm. The interstellar medium contains radiation levels that would pose serious threats to unprotected life, making our heliosphere a crucial barrier against galactic hazards. Voyager's data shows that this protection varies as our solar system moves through different interstellar environments over millions of years. The spacecraft's measurements of density variations and magnetic field changes suggest our cosmic neighborhood is far from uniform. We're traveling through a complex landscape of radiation zones, magnetic boundaries, and plasma clouds that create an ever-changing environment around our solar system. Understanding these variations helps explain long-term climate patterns and cosmic ray exposure cycles that may have influenced life's evolution on Earth.
The eternal journey.
Beyond its scientific mission, Voyager 1 carries humanity's most enduring message to the cosmos. The golden record attached to the spacecraft contains sounds, music, greetings in 55 languages, and 116 images representing Earth's diversity. This time capsule is engineered for extreme longevity, designed to survive over 1 billion years in the harsh environment of space. In approximately 40,000 years, Voyager 1 will make its closest approach to the star Gliese 445, passing within 1.6 light-years of this distant red dwarf. Long after Earth's continents have shifted beyond recognition, long after human civilization has evolved or disappeared, this record will endure. Voyager represents humanity's most lasting trace in the universe, an ambassador that will outlive our species. No other human object will leave the heliosphere for decades, making Voyager literally our longest-lasting monument. The spacecraft transforms from a scientific probe into something more profound, a message frozen in time, carrying the essence of who we were in 1977 across the galaxy for eons to come. This cosmic time capsule gives Voyager significance that transcends its scientific achievements, becoming humanity's first tentative step into eternity.
Redefining reality.
The space beyond our solar system isn't the featureless void astronomers once imagined. Voyager 1 has revealed a dynamic structured environment with weather patterns, magnetic topography, and radiation zones that shape our galaxy's invisible architecture. The transition from our solar bubble to interstellar space isn't clean. It's messy, complex, and honestly pretty fascinating. Magnetic fields don't align as expected, radiation environments change dramatically, and plasma waves suggest constant activity we never knew existed. Voyager's discoveries prove that interstellar space has layers, fronts, and boundaries, creating a textured cosmic landscape far more intricate than anyone predicted. The spacecraft continues operating on borrowed time, with NASA making difficult decisions about which instruments to shut down as power gradually fades. Early 2025 saw the cosmic ray detector powered down to extend the overall mission, but 3 science instruments continue transmitting their faint 23-watt signals across the cosmic void. Each day, Voyager 1 operates as a gift of knowledge from humanity's only direct sampling of the space between stars, rewriting textbooks with every transmission from the interstellar frontier. Voyager 1 reached the other side, and the reality is more extraordinary than fiction. The interstellar medium isn't empty. It's a structured, dynamic environment that challenges our understanding of cosmic architecture. From magnetic mysteries to plasma whispers, from radiation avalanches to cosmic weather patterns, Voyager continues revealing secrets that rewrite astronomy textbooks. This incredible journey proves that sometimes the most profound discoveries come from the simplest act of reaching beyond our boundaries. If you love real space exploration without the hype, smash that like button and subscribe to Stellar Tech for more mind-blowing cosmic discoveries. The universe is far stranger than we thought.